Over the last few class periods, we've been talking about relations, and we defined a relation as any set of ordered pairs. So if I were to now create a relation, and let's say that I'm going to use the following ordered pairs. I'm going to say that this is 2, 1, 3, negative 2, 2, 4, and 0, negative 2. And close up my set with the brace. And there is a relation. It's any set of ordered pairs. And we know that from that relation, we can go ahead and list the domain values, which are our x values. And so that is going to be 2, 3, 2, and 0. And so when we look at that domain, there's really actually 3 unique components of the domain, and that is going to be 0, 2, and 3. And that's because we have a repeat here in the domain, so we don't have to enter it in twice, okay? We then have the next part, which we know is our y coordinates, our y values, which is called our range, also our output, or our dependent variable. And so that is 1, negative 2, 4, and negative 2. And so we have negative 2 is our lowest, and we have 2 of those, so we don't have to put them both in there. And then we're going to have 1 and 4. Today we're going to take the idea of a relation and we're going to move it up a little bit, and we're going to talk about a function, okay? So a function is a relation, so it is a set of ordered pairs, but it has something specific about it. It tells us that each input has exactly one output. So what that means is that when we go to map or place in a table, or as we've already written our domain and our range, then we only need to have we only can have unique x values. So once we wrote down 0, and then we wrote 2, but there were actually 2 2s here, that means that this is just a relation. This is not a function because we have the repeat of this x value and this x value. So if we were going to just change one point from this relation to make our function, we could say, well, we have 2, 1, and 3, negative 2. But then once we get to this point here where we have 2, 4 again, we wouldn't want to include that because it has a 2 also. And so then we would remove that. And if we put 0, negative 2 in there, now this is a function, okay? This is not a function, it's just a relation. Now that we look at the x values here, we have a 2, a 3, and a 0. Each one of those x values are unique, and so there are no repeats in the x value, okay? And so when we have the ordered pairs, that's what tells us whether or not we have a function or a relation, okay? So yes, this is a function. Y, no repeats in the x value. or input value. Okay. One thing I want you to notice though is, do you notice that there is a repeat in the y value? And for our purposes of identifying whether or not this is a function, we are allowed to have a repeat in the y value. We're only specifically looking at the x value. So it is okay to have this repeat here. And I think when we look at that graphically, we'll see what exactly that means and why we are allowed to have it. First, though, we're going to look at how do we tell a relation is a function if we are starting with a table, if we are giving with a table. So if we look at the definition here, you can see that it's where each input has exactly one output. And the reason why this one was a function is there are no repeats in the x value. So what we need to do is inspect the x value. Remember, that's the x value, the input, the domain, or the independent variable. Those are all the names we could use for that right here. When I start to look at those, I've got a 1 and a 1, a 2 and a 3. But since this value repeats in the inputs, that is not a function. So we can identify that as just a relation. It is not a function. Okay. Let's look at this one here where we have input values here, 1, 2, 3, 4, and output values. To judge whether or not it is a function, we look at the input, 1, 2, 3, 4. Since those were unique, this is a function. Okay, so how do we tell when a relation is a function given a table? We're going to look for repeats in the x value. Okay, now we left some space over here, and that's because we know that a table and a mapping has similar components, but I did want to take a second and show you what each one of these would look like in a map. Okay, so if we looked at the input for this one here, and we went and made it into a map, we would have a 1, a 2, and a 3. And then for the output, we would have a 3, a 4, a 5, and a 6. And then we're going to take and we're going to look at our ordered pairs. So 1 goes in, 3 goes out. So we're going to go 1 to 3. The next thing here, 1 goes in, 4 goes out, 1 will go to 4. If we look at the next one, 2 will go to 5, and 3 will go to 6. Okay. If we look right here, do you see what happens? The 1 goes to the 3 and the 1 goes to the 4. And we have said that a function is a relation where each input has exactly one output. If we can see these two maps coming off of the same input value, that confirms this is not a function. Okay, but that's the visual of what it looks like. This part right here, where we see this map going here and here, that tells us it is not a function. Okay, let's look at the map of the next one here. If we have 1, 2, 3, 4, and then we have a 3, another 3, a 4, and another 4. Okay, so let's go ahead and start to map this. 1 goes to 3, 2 goes to 3, 3 goes to 4, 4 goes to 4. So if we look at this right here, we can see that for each one of these, we have one value going to one value. We have the second value going to that value. Remember what we talked about up here is that it's okay to have this and this, okay? That means that there's repeats in there. There's a repeat of 3 here and a repeat of 4 here, and it's okay to repeat there. Okay, so that is an example of how do we tell a relation, what it looks like in a table, and what a function looks like in a table, and then what a mapping, what that looks like when it's not a function and when it is a function. Not allowed to have the x repeat here. You are allowed to have the y repeat. Okay, let's go to see how do we determine if we have a relation. Okay, so what I want you to do right now is I want you to plot these points on this graph and plot these points on this graph. So go ahead and pause the video while you do that. All right, so now that we have those points plotted, I want you to pay close attention to where you have plotted the points 1, 3, and 1, 4. Those were the points that we identified that had an x value repeat and therefore made it not a function. If you look here, do you see how this point and this point, the 1, 3 and the 1, 4, happen to fall on the same vertical line? And so how we tell a relation is a function is to look at the vertical line test. What the vertical line test tells us to do is if we take a vertical line okay, and if we move that vertical line, oops, so now if we take that vertical line and we move it across the graph, when we use a vertical line, we start at the left and go to the right. And so if we move this vertical line across the paper here, you're going to see that it only hits the 1, 1 and or the 1, 3 and the 1, 4 at the same time. And so therefore, with those two vertical or those 2 points, because they have the same x value, they line up on the same line. If we keep going to the other graph here, you can see that it hits that point only, that point only, that point only, and that point only. And you can see that that is why we have that vertical line test when we use a graph. We don't have to actually go down and look at all of the pairs or write down all the ordered pairs and look for repeats. We know where repeats visually occur. They occur where we have 2 points on the same vertical line. Okay, if we were to take a look at these two graphs, if we wanted to determine if they're going to be functions, we are just going to use that vertical line test. So I'm going to take and I'm going to draw a vertical line. No, for some reason I'm having a hard time drawing my vertical line. Give me 1 second. All right, so we're going to take this vertical line and we're going to see as we move this vertical line across the graph, can you see that it starts to hit points the same x value at the same time? Okay, so if we're looking here, you could see that both of these graphs here, this x coordinate and this x coordinate would be the same. And in fact, that would happen in several different places as you move this graph across this, or this vertical line across this graph. So that means that this is not a function. Okay. If we do this here, we have our vertical line, and if we move this across the page, you can see that at any one point, it is hitting, our vertical line is hitting our graph just in one place. And so therefore, we do not have any repeats in the x value, and this is a function.